I wanted to give you guys an example of balancing a redox reaction in acidic conditions. So here's a reaction where we have dichromate reacting with hydrogen sulfide to form chromium 3 plus in solution and solid sulfur. So the reason why you'd want to understand a reaction like this is sometimes you want to synthesize something that's already in another compound. So if you oxidize the sulfur to solid sulfur, you can synthesize pure sulfur. So like any reaction, the first step is we want to determine the oxidation state for most of the species involved in our reaction. So the easy ones are chromium, so chromium 3 plus. Remember, if you have an ion in solution, its oxidation state is just going to be the same as its charge. So it's just 3 plus. And sulfur is also easy, solid sulfur, so if you have sulfur in its elemental state, it's just going to be 0. And if you look at sulfur inside H2S, so now each hydrogen is +1, so our sulfur must be -2, and our hydrogen's +1. And over here, our chromium, you can set up a algebraic expression if you don't want to do this in your head. So we don't know what chromium is, so we're going to say 2 times X for the oxidation state of chromium plus 7 times 2, we have 7 oxygen atoms that each have an oxidation state of 2, is equal to -2. So the sum of the oxidation states need to add up to your overall oxidation state. So if you work all of this out, you should get that X is equal to +6 for chromium. All right, so we see that chromium went from +6 to +3. So remember that Leo the lion says grr. So chromium is gaining electrons and is therefore reduced. And sulfur is losing electrons and is therefore oxidized. All right, so our next step is that we want to set up our half reactions. So we can go ahead and say that Cr2O7 2 minus, so we're gaining electrons, and we have 2 chromium atoms that are each gaining 3 electrons, so we need to do +6 electrons to go to 2 chromium 3 plus. So now we can write out the half reaction for the oxidation. So for the oxidation we have H2S losing 2 electrons to go to solid sulfur plus 2 electrons. Okay, so now we need to balance the oxygen atoms and the hydrogen atoms in each of these half reactions, because in this reduction half reaction our oxygens are not balanced, and in this oxidation half reaction our hydrogens are not balanced. To balance the oxygens in the reduction half reaction, we need to add water to either side of the reaction to balance the oxygens, because this is an aqueous solution, so we can easily do that. So here we have 7 oxygen atoms on the left-hand side, and we don't have any on the right-hand side. So we're going to add 7 waters to the right-hand side of our reaction. And now our hydrogens are not balanced, but luckily we're in acidic conditions, like was stated in the problem. And so we can add H plus or hydronium ions to the left-hand side. So now we have 14 hydrogen atoms on the right-hand side, so we're going to add 14 H plus to the left-hand side. And so now our chromiums are balanced. We've got 7 oxygens, 14 hydrogens, 14 hydrogens. The next step is you want to make sure that your charges are all balanced. So here we have a charge of +6, Over here we have 14 plus negative 2, which is positive 12, plus negative 6 is positive 6. So we also have a balance of charge on either side. Okay, so now let's go ahead and do the oxidation half reaction. Here we just need to balance our hydrogens. So all we need to do is, because we have 2 hydrogens on this left-hand side but none on this right-hand side, we simply just need to add 2 H plus onto the right-hand side. And again, now hydrogen's balanced, sulfur is balanced, and our charge, we've got overall 0 on this side, 0 on this side. Alright, so the next step would be to add these two reactions together, but before we can do that, we have to make sure that our electrons are balanced. And the reason why we do this is because electrons have to be transferred. They have to be going from one place to another. They can't just be floating around in solution all by themselves. So what we're going to do is we're going to multiply our oxidation half reaction by 3. And when we do that, we'll have 6 electrons on the right-hand side and 6 electrons on the left-hand side, so they'll completely cancel out. So I'm just going to go ahead and add these two together. So we have 14H plus 3 hydrogen sulfide plus Cr2O7 2 minus plus, sorry, this should be going to 2 chromium 3 plus 3 solid sulfur plus 6H plus 7 H2O. And again, we can simplify this because we've got 6H plus here, we have 14 over here, so 6 of our H plus are going to cancel out. This is going to become 8, and now we can further simplify this reaction. We have 8H plus 3 H2S plus our dichromate Cr2O7 2 minus going to 2 Cr3 plus 3 S solid sulfurs plus 7 H2O. Alright, so again we can just double check that everything is balanced on either side, and we have 8 plus 6 H plus over here, so that's 14. We have 14 here. We have 3 sulfurs, 2 chromiums, 7 oxygens, 7 oxygens. So now this is finally a balanced redox reaction. So remember that when you're balancing an acidic solution, all you need to do is add water to balance the oxygen, and then you just add hydrogens to, or I'm sorry, hydronium ions to balance the hydrogens. Okay, so now we want to see how this would change if now we were no longer in acidic conditions, but now we were in basic conditions. And it's really not very different. You follow all of the same initial steps, balancing the oxygens with water, balancing the hydrogens with H+. But the only issue is in basic conditions you can't have H+ floating around in solution. So now we must add enough hydroxide to balance out the hydronium ion. So we'll add 8 hydroxide on this side to balance with the H+, and then we'll add the same on the right-hand side plus 8 hydroxide. So now that we've added hydroxide to both sides of the equation, this H+ and hydroxide is going to combine to form water. So now if we add all of this together, we're going to get 8 water plus 3 H2S plus our dichromate plus our chromium 3 plus our sulfur plus 7 waters plus 8 hydroxide. This is our hydroxide. Oops, kind of falling off there. Okay, so now we've got 8 waters here, 7 over here, so 7 of those waters can cancel out, and we'll just be left with water plus 3H2S plus our dichromate going to chromium 3 plus our sulfur plus 8 hydroxide. Okay, so now we can check that everything is balanced, and we've got 7 plus 1, 8 oxygens. We have 8 oxygens over here. We've got 6 plus 2, we have 8 hydrogens. 8 hydrogens here. 3 sulfurs, 2 chromium, 2 chromium. We can also check charges. So overall we have -2 on this side. Overall we have +6 plus -8, so -2 on this side. So charges are balanced. Everything is balanced.